In this lesson, we're going to expand binomials, but before we do so, I want to look at these binomials that have already been expanded for us to consider some of the patterns that we notice. So we start off with x plus y to the 0 power, which equals 1. Here we have x plus y to the 1, which would therefore be x plus y. Here we have x plus y quantity squared. So if we rewrote this and then distributed or FOILed, we'd get x squared plus 2xy plus y squared. Right here we have x plus y to the third. So if you rewrote this 3 times and then distributed and combined like terms, you would get this expansion. And then same thing for x plus y to the fourth and x plus y to the fifth. So if you look through the expansions, you'll notice some patterns. First, powers of x decrease. So right here, for example, you have x plus y to the fifth, and if you'll notice on the terms, the x variable goes down in power. So it starts x to the fifth, then x to the fourth, and third squared to the 1, and then no x. You'll also notice that the powers of y increase. So right here you can see there's no y, then it goes y to the 1, y to the 2, y to the 3, and so on. And finally, the powers of each term will equal the power of the binomial. So again, back to this last example, we have x plus y to the fifth. This first term has x to the fifth. The second term, if you add the powers on the x and the y, you get 4 plus 1 makes 5. Right here you have x to the third, y to the second, so if you add 3 and 2, you get 5. Same thing here, x squared, y to the third, you add them, you get 5. Right here you have x to the 1, y to the 4, when you add those powers, you get 5. And then obviously this last term is also a power of 5. Next, we're going to fill in the coefficients of the above expansions. So for this first expansion, the coefficient is just 1. For the second expansion, the coefficients would be 1 and 1. Right here you have coefficients of 1, 2, and 1. Here you have coefficients of 1, 3, 3, 1, and so on. We're going to fill them into the triangle. Over here, when it says row number, that's going to correspond to the exponent on the binomial. So finally, we want to fill in one more additional row. You can see just by the pattern that the outside numbers will be 1, and then going down you can see that these would be 6. Finally, we're going to fill in these last 3 values. To do so, I want to look up above right here. Right here you have 4, 6, and this number is a 10. Right here you have 6 and 4, and this number is a 10 as well. Right here you have 4 and 1, and this number is a 5. So you can see that the pattern is we're adding the 2 numbers above to give you the number that falls right below. So again, 6 plus 4 makes 10, 4 plus 6 makes 10, and 1 plus 4 makes 5. So if we continue that pattern, 1 and 5 made 6, 5 and 10 adds to make 15, 10 and 10 makes 20, and 10 and 5 makes 15 again. So now in theory, you could keep filling out this triangle with more rows by adding the 2 numbers above to give you the next value. And I put a little note right here. The mathematician who is given credit for this is Blaise Pascal, and this is called Pascal's triangle. This example says to expand the binomial x plus y to the fourth. So what we're going to do is by using the patterns that we noticed on the left, we're going to expand this binomial. And so to expand this, we're going to do this purely based on those patterns. Because this binomial is being raised to the 4th power, we're going to start with x to the 4th. Then we're going to drop down x to the 3rd, x squared, x, and the last term will have no x's. For the y's, we're going to do the opposite. This term will have no y's. This term will be y to the 1. This will be y to the 2, y to the 3, and then this last term will be y to the 4. Our last step is we want to fill in the coefficients. So the coefficients, again, they come from Pascal's triangle. So without looking at the left side of the notes, I want to draw Pascal's triangle up here. Pascal's triangle starts 1, 1, 1. Then the next row is going to be 1, 2, 1. And then again, you're adding to get the next row. And because this binomial is being raised to the 4th power, we need one more row. So it's 1, 4, 6, 4, 1. And here are the coefficients to this binomial expansion. So let's go ahead and fill them in. This would get a coefficient of 1, this would get a 4, and then 6, then 4, then 1. So x plus y to the 4th becomes this expansion. X to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. So we're going to do the same thing on this example. It says x plus y to the fifth. So we start with x to the fifth, and then we keep going down in powers. And then the y's do the opposite. No y, y to the 1, y to the 2, y to the 3, and so on. Finally, we just need the coefficients. And so again, that's going to be on Pascal's triangle. If I go back up here, I can fill out one more row, and I get 1, 5, 10, 10, 5, 1. So let's fill them in. 1, and then 5, 10, 10, 5, 1. And here's our expansion using the patterns. For this example, we have x plus 5 to the third power. So this problem is different than the two previous problems because we don't have x plus y. Instead of a y, there's a 5 in place of it. So what we're going to do is we're going to use this chart. Because the binomial is being raised to the third power, we're using this row 1, 3, 3, 1 for the coefficients. So let's go ahead and fill those in. For the next column, since we have just x, we're going to start x to the third, x to the second, x to the 1, and then no x. The y's are going to do the opposite. There's no y, and then in theory it would be y to the 1, y to the 2, and then y to the 3. But instead of a y, we're replacing it with a positive 5. And this last column is so that we can multiply across. 1 times x cubed just makes x cubed. Here, when we multiply across, we have 3 times x squared times 5 to the 1, so you get 15x squared. And then right here, we have 3 times x times 5 squared. 5 squared is 25, 25 times 3 is 75x. And for this last row, we just multiply 1 times 5 cubed, and you get 125. So our expansion is going to be these terms. Let's go ahead and write them out. So we get x plus 5 to the third power equals this expansion. For this problem, we have x minus 2 to the fourth power. Because our binomial is being raised to the fourth power, our coefficients, according to Pascal's triangle, are going to be 1, 4, 6, 4, 1. Next, the x is just x, so we're going to start with x to the fourth, then go x cubed, x squared, x, and no x. In place of the y term, we have negative 2. So the pattern for the y's would be no y, y to the 1, y to the 2, y to the 3, y to the 4. But instead of y, we're going to replace it with negative 2. So first I like to just put parentheses for the y to the 1, y to the 2, y to the 3, y to the 4, and next I'm going to fill in negative 2 for all of those y's. At this point, we're going to multiply across to get the terms. 1 times x to the fourth makes x to the fourth. 4 times x cubed times negative 2 to the 1 makes negative 8x cubed. When we multiply this row, negative 2 squared makes 4. 4 times 6 is 24. X squared. Right here, negative 2 to the third power is negative 8, times 4 is negative 32x, and finally negative 2 to the fourth is 16. So here's our binomial expanded out. For this example, we have 7x minus 1 to the third power. Because our binomial is being raised to the third power, according to Pascal's triangle, our coefficients are going to be 1, 3, 3, 1. Okay, next, in the x position, we have 7x. So what I'm going to do is I'm going to use parentheses. So using parentheses, we have to the third power, to the second, to the first power, and then no x's. We're going to substitute in 7x for all of these parentheses. In place of y, we have negative 1. So here, this would be no y, then y to the 1, y to the 2, y to the 3. And again, in place of y, we're going to plug in negative 1. At this point, if you need to grab a calculator, go for it. 7 to the third power is 343, times 1 is still 343, and then you also have x cubed. So there's our first term. For this next row, we have 7 squared, which is 49. Then we need to multiply that by 3 and negative 1 to the 1. So 49 times 3 is 147, and then we're multiplying that by a negative. Right here you have 7 to the 1 times 3, and negative 1 squared is positive 1. So you end up just getting 21 x to the 1. And last row, this makes, when you multiply these, negative 1. So here's our binomial expanded. 343x cubed minus 147x squared plus 21x minus 1. For this example, we have the binomial raised to the fifth power. So according to Pascal's triangle, our coefficients are going to be 1, 5, 10, 10, 5, 1. For the x term, we just have x. So we're going to start with x to the fifth and then go down. For the y's, we have no y. And then we'll go y to the 1, y to the 2, y to the 3, y to the 4, and y to the 5. If we look in the original problem, in place of the y, we have 3y. So we're going to fill in positive 3y for all these parentheses. Finally, we're going to multiply across. And feel free to use a calculator, just make sure you do the exponents first, then multiply by these numbers over here. So here's all our terms. Let's go ahead and write this out. All right, and here's our binomial expansion.